Hello everybody. So today we'll be looking at this very interesting problem from the International Mathematical Olympiad. So our goal is to find the smallest positive integer t such that the sum from I equals 1 till t of xi to the power 3 is 2002 to the power 2002. So it is quite interesting to first try and work modulo 9. So the first thing we notice is that 2002 is congruent to 4 mod 9. So 2002 is congruent to 4 mod 9, which implies that 2002 to the power 2002 is congruent to 4 to the power 2002 mod 9. So basically, instead of working with 2002 to the power 2002, we simplify it into 4 to the power 2002 in modulo 9. So now when we consider powers of 4, we can notice that first of all 4 is congruent to 4 mod 9, 4 to the power 1. When we move up to 4 to the power 2, which is a 16, so basically we can see that it's 7 mod 9. And when we look at 4 to the power 3, so basically 4 to the power 3 is equal to 64, and 64 is 54, it's 1, which is 1 modulo 9. And if we look now at 4 to the power 4, which is I think it's gonna be 4. Yes, it's 250. Yes, it's a 4 mod 9. So basically we have a cycle of 4, 7, 1. So all we gotta do is find 4 to the power 2002. Like, is it 4, 7, or 1? So basically it's the same as finding the residue when 4 to the power 2002 is divided by 3, which is 1, which means that the answer is 4. So basically 2002 to the power 2002 is actually congruent to 4 modulo 9, which means that the sum from I equals 1 until t of xi to the power 3, which is the same as x1 to the power 3 plus x2 to the power 3 all the way up to xt to the power 3 is actually congruent to 4 modulo 9. So now if we consider each one of these terms independently mod 9, we can very easily notice that if a is, for example, a can be occur 0, 1 to all the way up to 8 mod 9. So if we cube this, I mean that's a very useful result you can use in number theory Olympiad problems. It's either 1, negative 1, or 0 mod 9. So in order to reach 4 mod 9, so I mean we cannot do that with 1 term. We cannot do that with 2 terms, and we cannot do that with 3 terms. So we need at least 4 terms in order to reach 4. So we can see now, oops, I'm sorry. We can see that t is actually greater or equal than 4. So now all we have to do is check whether t equals 4 works or not, because we want the least t. So if t equals 4, we just need to find 2002 to the power whether this equality is true or not, equals to x1 to the power 3 plus x2 to the power 3 plus x3 to the power 3 plus x4 to the power 3. I mean, we can do that using quite a beautiful trick. It's 2002 times 2002 to the power 2001. We did that because 2001 is a multiple of 3, so it's going to be really helpful. So now we can make this as, if I'm not mistaken, 2001 over 3 is the same as 667. Sorry. Yes, it's the same as 667 all to the power 3. So now we can turn this into 2 times 10 to the power 3 plus 2 times 2002 to the power 667 all the way to the power 3. So now it becomes quite easy. It's 10 times 2002 to the power 667 all to the power 3 plus 10 times 2002 to the power 667 all to the power 3 plus 2002 to the power 667 all to the power 3 plus 2002 to the power 667 all to the power 3. So our final answer is t equals 4.